Welcome back. In this lecture, we are going to learn about EMF equation of transformer. EMF equation of transformer, one of the most important topic in electrical machines. We'll cover the concept, derivation, and finally understand why the famous formula E is equal to 4.44 F N phi m comes into play. So this is our today's topic. So let's start. For electrical transformer, the EMF equation is the mathematical expression used to find the magnitude of EMF, induced EMF in the windings of the transformer. So consider a transformer shown in figure N1 and N2. This is the primary turn and this is the secondary turn of the transformer. When we apply an alternating voltage V1 of frequency F to the primary winding, an alternating magnetic flux phi is produced by the primary winding in the core. Now if we assume that sinusoidal AC voltage, then the magnetic flux can be given by phi is equal to phi m sin omega t. So this is the equation 1. Now according to the principle of electromagnetic induction, the instantaneous value of EMF E1 induced in the primary winding is given by E1 is equal to minus N1 d phi by dt. We know that this phi is equal to phi m sin omega t. This is phi m sin omega t. So we can write E1 is equal to minus N1 d dt phi m sin omega t. Now we can write E1 is equal to minus N1, that omega is constant, phi, the derivative of sin omega t is cos omega t. So we know that omega is equal to 2 pi f. So we can write E1 is equal to minus 2 pi f N1 phi m cos omega t is minus cos omega t is equal to sin omega t minus 90. So therefore we can write E1 is equal to 2 phi f N1 phi m sin omega t minus 90 degree. That is minus 90 degree. So this is equation number 2. Equation 2 may be written as E1 is equal to E m1 sin omega t minus 90 degree. So this is equation 3, where E m1 is the maximum value of induced EMF E1. So this equation number 2 can be written as this EM1 sin omega t minus 90 degree. So this EM1 is equal to 2 pi f N1 phi m. Now for sinusoidal supply, for sinusoidal supply, the RMS value of E1, of primary winding, is given by E1 is equal to E m1 by root 2, so that we can write 2 pi f n1 phi m by root 2. So after simplifying this, we can write E1 is equal to 4.44 f phi m n1. So this is equation number 4. Similarly, RMS value of secondary winding can be written as that E2 is equal to 4.44 f phi m n2. So this is equation number 5. Okay, here again I am writing the EMF equation for the primary and the secondary winding. That EMF equation for primary winding, we can write E1 is equal to 4.44 phi f phi m n1. This is 4. Then for the secondary we can write E2 is equal to 4.44 f phi m n2. This is equation 5. So in general we can write that E is equal to 4.44 f phi m n, and this is equation number 6. This equation 6 known as EMF equation of a transformer. EMF equation of a transformer. Now if we divide the EMF equation by supply frequency, we get E by F is equal to 4.44 phi mn is equal to constant, which means the induced EMF per unit frequency is constant, but it is not same on both primary and secondary side. Secondary side of the transformer. of the transformer. Also from equation 4 and 5, that means equation 4 was E1 is equal to 4.44 F phi m N1, and equation 5 was E2 is equal to 4.44 F phi m N2. So from these two equations we can write E1 by E2 is equal to N1 by N2, or we can write E1 by N1 is equal to E2 by N2. So we can write the induced EMF per turn in the primary winding is equal to the induced EMF per turn in secondary winding. Now we'll see one example where these formulas are applicable in the transformer. So take an example is single phase 3300 by 240 volt 50 hertz transformer has a maximum magnetic flux of 0.0315 Weber in the core. Now we need to calculate the number of turns in primary and secondary windings. So here primary voltage, secondary voltage, frequency and flux is given. So from this we need to find out the turns in primary, means N1, and secondary turns, that N2 we need to calculate. Okay, let's see solution. So we know that EMF equation of the transformer is E is equal to 4.44 F phi m N. Now for the primary winding, now EMF equation for the primary winding is E1 is equal to 4.44 F phi m N1. So now we can write N1 is equal to, so we can write N1 is equal to E1 by 4.44 F phi m. Now we know the value of E1 is, the primary voltage is 3300. This is the primary side voltage, so that we can write 3300, and this is 4.44 into 50 hertz into, so that value is flux is given 0.0315. so after calculating we'll get 471.9. so we can consider that is 472 turns, so that this is the primary turns. Now similarly we can find out the secondary turns. So for EMF equation we can write E2 is equal to 4.44 F phi m N2. So for N2 we can write E2 by 4.44 F phi m F phi m. So this is E2 is given 240 volts. This is 4.44. Frequency is 50 Hz and flux is 0.0315. So this after calculation it will come 34.32. 34.32. So in a round figure we can take 35 turns. So this is the calculation of primary turns, and this is the calculation for the secondary turns. So from this lecture we have understood what is EMF equation of transformer, transformer, and with an example we have understood so how to find out that value of primary turns and the secondary turns. So thank you everyone. Thank you for the listening.